Hello, welcome to Einstein Mechanics. In this episode, we are going to solve problems on rectilinear kinematics, that's continuous motions in a straight line. So let's look at our first problem and tackle that. So this is our first problem. A bus starts from rest with a constant acceleration of 1 meter per second square. Determine the time required for it to attain a speed of 25 meter per second and the distance traveled. So this is very simple. Let's write down our parameters. So first, we are seeing that the bus is starting from rest. Pay attention, from rest. So from rest means we are going to have our initial velocity. Mostly we refer initial velocity to be 0, right? Okay. And it has an acceleration of 1, which is 1 meter per second square. Determine the time required for it to attain a speed. And this is also a speed, which is meter per second velocity, right? So that is going to be our final velocity V. And that is 25 meter per second. So at rest means per second this way. And we are interested in finding the time that we have and the distance s. Very good. So in the previous episode, we saw how we can integrate functions and differentiate them to get the various acceleration and velocity or displacement. But here, what do we see? We see that there's no function given, only the parameters are given. So another way to solve for time, distance, or velocity in dynamics is to make use of Newton's motion equations, right? The motion equations. So first, the motion equation, we are going to make use of the first one, which says the final velocity is equal to the initial one plus acceleration and time. And the second one is also x is equal to, which is the displacement or the position, the ut plus half at square. And the third one is also, we have our v square is equal to u square minus 2as this way. Very good. So the equations of motion is also going to help us to solve our problems. When we look at the parameters and what we are interested in time. From the equation 1, we can make use of that equation to get our parameters. So from v is equal to u plus at. We know that the final velocity was given as 25. So 25 is equal to the bar started from rest, which means the initial is 0, plus an acceleration of 1 and a time that we are interested in. So this is going to give us 25 is equal to t. Therefore, the t is after 25 seconds. So it attained this speed after 25 seconds. Very good. Now, let's look at the distance traveled, which is s. From the equation 2, where we can say our x is equal to ut plus half at squared. If we are interested in the distance traveled after this time with the parameters given, then we can say our x is still started from rest. So u is t is 0 and the t is what, 25. So minus 25 plus this is half. The acceleration is still 1 multiplying the t 25 square. So this is going to give us, all this is going to 0. So that is 0 plus half by 1 by 25 square. Very good. All right. So with this, we are going to see this to be equal to 312.5, and since it is a distance traveled, it is going to be meters. Very good. So using the Newton motion equations are also a way we can use to solve dynamics questions. Now let's look at question 2. Maybe you have a different approach. All right, so example 2. What do we have? Example 2 says when a train is traveling along a straight track, because we are talking about continuous motions, it's supposed to always be a straight line at 2 meters per second. So the initial velocity is what? 2 meters per second. It begins to accelerate at a function. So acceleration is given in terms of a function 60v raised to the power negative 4 meter per second squared, where v, the velocity, is in meter per second. Now determine its velocity, that's the final velocity v. Because we are given initial velocity, we are to determine final velocity and the position x after 3 seconds. So this is interesting. So first, let's write down our parameters. So our solution is that we have our first, we are going to have the parameters. So v, or my a, is 60 v negative 4 meter per what? Second square. Then I have my velocity, or v1, the initial one, which is 2 meter per second. Also, I have my time. All this they are happening at a t is 3 seconds. So I am to look for the final velocity 2 is unknown, and I'm also to look for the position x, and that is also unknown. Very good. So to know the velocity, I know that acceleration is going to be dv on what? dt. Right. Do I have a function for acceleration? Yes. So that means I'm going to have a function this way. 60v negative 4 is equal to dv on dt. Now watch this very well. This is calculus. If you try to bring the dt here to be like 60v negative 4 dt and you integrate, it won't be possible because the function is in terms of v and this is dt. So it won't work. So you have to make it 60v minus 4 dv such that you can integrate v with respect to dv. That is how calculus works. How it goes. So since we have that idea, now let's try to bring the dv instead. Pay attention. This is a special type of problem that we mostly encounter. So meaning I'm going to have dt is going to be equal to my dv on 60v negative 4 this way, right? Okay, so can I say this implies that dt is going to be 60. Now if the v comes up, it is going to be positive 4 dv. So I can now apply my integration. Time is from 0 to t, and here velocity is going to be starting from initial velocity, which was 2, right, to a certain final velocity v that we don't know. So I'm going to interchange the position of the t and send it to the right hand side and bring this one such that I'm going to have it this way, where my analysis is going to be easier. Alright, so here if I reciprocate the v, I'm still going to have it as 1 on 60. Yeah, my 60 is still down, but I reciprocated the v. Is that right? Okay, so meaning this is what I'm going to get. I'm going to factorize the 1 on 60 out such that I'll have 1 on 60 integral of v for dv equal to the integral of up to the t. This is what I have. Are we good? So this is also from the initial velocity 2 to v. Now this is simple integration that we can do. So this is still going to be 1 on 60. If I integrate this, this is going to be v5 on 5. Now the limit is going to be from 2 to v of that equal to. This is just like integrating a constant, which is 1 dt. So that is also going to be, it will come as t from definite integral 0 to t this way. Are we good? So now I'll prefer that this 5 will come out, which is 1 on 60 by 5, still having v5 2 to v equal to t, the integral 0 to t. So let me try to put in the limit. So that is going to be 1 on 300. So putting in the first v will be v5 minus 2 raised to the power what? 5. This is it. Equal to now t. If you bring this t to be t minus 0. That way. Are we good? Okay, so this is 1 on 300 v5. This is going to minus 32 equal to t. So from here, I can make v the subject to get the function of v. And from here, if you make v the subject, your final v is going to be 300t plus 32. That will be the fifth root. So fifth root means 1 on 5. Try making it the subject. You get this expression for your v. So now we are finding velocity at time 3. So let's put in the value of 3. So that is going to be v is equal to 300 by 3 plus 32 raised to the power 1 on 5. And our velocity is going to be 3.93 meter per second. So therefore, the velocity v after 3 seconds is 3.93 meter per second. Are we good? Now we are left with the position x, and we have the function of v. What do? We have to also integrate the function of v to get our x. So this is what we are going to get. So already this is our v function. Our v function is going to be 300t plus 32 on 1 on 5. And we also know that v is the x dt. Now v function, let's put it in, which is, this implies that the v function, which is 300t plus 32 ds on dt. This time you don't need to bring the ds to the function because it is in terms of t, so the t can now come, right? Okay, so this is going to be dx is equal to 300t plus 32 1 on 5 dt this way. So we are going to apply our integrals. So the x is going to start from 0 to x, and the time is going to start from 0 to a certain time t. Now when we integrate the left hand side, we are just going to get an x, which is going to be the integral 0 by the t. What time are we looking at? We are looking at 3 seconds. You can put t or bring the 3 seconds. This is our function, 300t plus 32 raised to the power 1 on 5 dt. So integration of this function, this is calculus integration by substitution. So we can use that. So let's dive into the calculus. I can say let my u be equal to 300t plus 32, which implies that du with respect to the t is going to be just 300. Because I'm introducing a u, this dt should be in terms of u, which implies that my dt now is going to be du on 300. Are we good? And this is definite integrals. Anytime you introduce a u into the integration, the limits are going to change. So here, if you want to know the limits, you're also going to say your u is going to be equal to whatever you have. This is u. Put in the value of the t as the integral. So if u is 300t, the upper one is, this is the upper, by t, which is 3 plus 32, meaning the upper limit is changing to 932. Now the lower limit is also going to be the 300, which is the u, by what? 0 plus 32, meaning the lower limit is also 32. So practically this is what we are going to get. X integral from 932 to 32. The function is u 1 on 5, and we have the t as du on 300. So I'm going to, this is implying that my x is equal to, I'll take this as 1 on 300 out, then I'll cause the integration to this. This is going to be u 1 on 5 plus 1 on 1 on 5 plus 1. The integrals are having their limits. So this is 32 to 932. So x is going to be 1 on 300. If you solve, this is going to be u 1.2 divided by 1.2. So the limits 32, 932. They are there. Are we good? So if we can multiply through the 300 by the 1.2 to get what we want. So my x is going to be u 1.2 on, that is going to be 360 if you multiply, and from 32 to 932. If we put it in, that is going to be the upper limit 932 1.2 on 360 minus the lower limit, which is u 32 1.2 on 360. Are we good? And we are going to have 9.985. So this is the final answer. Therefore, our position is going to be 9.985 meters, because after integrating the velocity, this is where we are landing, and it is a figure for the displacement or the position of whatever we are looking for. Are we good? Let's look at the third and last example in this episode. It is very interesting. All right, so this is another example that we have that we are looking at. So this one says a train travels at v, and we have the v function given in feet per second, where t is the elapsed time in seconds. Determine the distance traveled, that is our s, in 3 seconds. And we also to determine the acceleration at this time. So like we know already, we have our v function, which is 61 minus exponential function negative t. So here it is basically calculus per second. So this is, I don't want to open the bracket, or I don't want to factorize the 60 out. I can say 60 minus 60 negative t, like this, which is feet per second, right? And I'm evaluating everything at t is equal to 3 seconds. I'm looking for the distance traveled, and I'm also looking for the acceleration that we are looking for, right? Okay, So the simplest one is to first look for the acceleration, which is the derivative of the velocity. So this is going to be the derivative of the function 60 minus 60 e negative t on the t. And as I always say, this is calculus. If you differentiate this function, if you differentiate the 60 here, it is going to be a constant. So that is going to be 0. And if you differentiate this part, the exponential function, to differentiate this, we first differentiate the part, the top, if it corresponds to whatever we are doing. This is the t and this is t. Yes, so if you differentiate negative t, we are getting negative 1. You multiply it by the whole expression. So if I multiply the whole expression by negative 1, that is going to remove this negative to positive. So that is going to be positive 60, the same expression, negative t, like this. So therefore, the acceleration function is 60 exponent negative t. Are we okay? And we want to find the acceleration at time equal to 3. So this is 60 e negative 3. And if we punch this on our calculator, we are going to get the acceleration to be 2.987. This is feet per second square. Alright, now if we want to find the distance where we know that our velocity is x on the t, the velocity function, we have it as 60 minus 60 e negative t ds on the t. You check this expression, is it in terms of the x or the t, so that you make it the subject. This is in terms of the t, so the t can come such that this will be the x equal to 60 minus 60 negative t dt. We apply the integral from 0 to x. Now we are interested from time 0 to what? 3. But we can still put in the value of what? 0 to t. We know that t is equal to 3. If we differentiate or integrate this left hand side, we are getting x. And since it is calculus, I'm going to do it very fast. If we integrate this constant 60, we are going to get 60 with the t attached to it. And if we integrate this part, it behaves like the e function behaves like the differentiation. So that part, we are also going to differentiate the top, which is the negative t, to give us negative 1. Then you divide the expression by that negative 1. So it is still going to take out this negative to get a positive 60 e negative t. But all these things, they are having their limit 0 and up to a t, which we are interested in to be 3. Are we okay? So here we are going to solve by putting in the limits, which is going to be 60 by 3 plus 60e minus 3 minus 60 by 0 plus 60 by e negative 0. Don't tell me this place is going to 0. No, the e function is going to behave differently. And if you punch this on your calculator, you are going to get 122.98, which is approximately 123. And since it is distance, we are going to give it as meters, m. Are we good? Yes. Now our unit is in terms of feet, so we are going to give it as feet. So this is going to be 123 feet. So this is the final answer. Thank you for watching this episode. Check out for the next episode. We are going to discuss more of the problems in detail. So second set of the problems are in the next episode. See you there. Please subscribe to the channel, like our videos, and drop your comment.